Okay, Lewis structures part 2, and this time I actually know what I'm going to teach. So first I find the element that I want to center my world around, aka put all of my elements at like my other elements. So for example, if we're doing C2H2, sorry, I want to change to H4. I would center my world around the carbons because carbons need 4 bonds to be stable, while hydrogen can only form 1 bond. Like, it literally cannot form 2. Like, it's just physically impossible for it. I mean, I don't want to use the word physically here because that has a different connotation in chemistry, but you get the point. It's just not possible. So we have our carbon, and then we have our other carbon. They better be besties. And then we have our hydrogen, and more hydrogen, hydrogen, hydrogen. I also just prefer writing it this way because it keeps them all spread apart and it's just less confusing for me visually. Because imagine putting like hydrogen and hydrogen next to each other and it's like, but like they look like this and you know that they're separate, but like they literally look like they're about to mix, and like just it looks like they're also trying to make a bond, which is just visually confusing to me. So that's why I don't do that, and that's why I always spread them apart like this. I'm sure we're not actually supposed to do that, and we're supposed to draw it chemically correct, like in the actual shape, but like I'm too lazy for that. So right now we will just stick with this fun way. I think I've already used this example, but this is just the only example I can come up with off the top of my head. Okay, so carbon has 4, and we have 2 carbons. And hydrogen has 1, and we have 4. So this in total is going to make 12. 12 is what we have to work with this time, just as before. So let's see. Yeah, as I mentioned before, hydrogen is never at the center of any of this because it only has 1 bond. So imagine I put hydrogen in the center of carbon and carbon. These two, they want to make a bond. They want to both be besties with hydrogen. But hydrogen can only be besties with 1. So now this carbon over here is like, what the heck? I want to be friends with you too. So now they have drama. They're beefing. Don't let your elements beef, okay? Get your hydrogen out of drama. Simply keep it out. They're happy. They're happy. This carbon doesn't even see this hydrogen. They're good. Everyone's happy. No one has any drama. That's probably the worst example I could have thought of. Oh well. Let me know if you have more questions, because as you can tell, I'm winging it. It literally just doesn't work if you put it in the middle, because this one wants to reach over to this carbon, and if you stack on more hydrogens, this one hydrogen cannot make a bond with any of these because it already has this bond. This is the only bond it can make. It can only make one. So this is why it just simply doesn't work, and that's why we always tack it on the outside, because this so drama free. Everyone's happy. No one sees each other except for carbons. Carbons 2 timing. Let's see. Oh yeah, then it's just like, oh yeah, you do your regular stuff, whatever. These are always guaranteed to have a just 1 bond line, because that's the maximum and the minimum that hydrogen can have. So once you have that figured out, this only leaves these 2. And carbon already has 2 bonds, and this carbon already has 2 bonds. So with the remaining electrons that we have here, 2, 4, 6, 8, we already have 8 here thanks to the hydrogens. we have 4 more to spare, so that means 2 more electron pairs. This makes it a perfect fit for a double bond between the carbons. Cool. Okay. And another thing I also wanted to talk about was with other elements like oxygen, oftentimes you're going to need to use it to bond with your carbons or other elements to increase the number of bonds to stable levels. In carbon's case, it's 4. Or you'll need it to bond your other elements in order to reach the required number of valence electrons, which in this case was 12, but obviously it's not always going to be 12. Yeah, personally, half the time I'm just winging it and editing my formula as I go, because obviously it's not always going to be as simple as this, as finding your hydrogens and then, oh wow, there's only 2 left. There can only be one possible solution. Yeah, so oftentimes you just have to edit as you go, and it really is just a very tedious process. I'm gonna go grab another example, because I feel like having a direct example would be really helpful for explaining what I'm talking about with oxygen. So for this one, I will choose, it's number 14 on the paper, H3 COH. Okay, so 3, 1, this is hydrogen, and then you have 1 carbon, 1 oxygen, and another surprise hydrogen. And this all adds up to 14 in the end. Once again, carbon's going to be the main star of the show. Just for now, even if I have to change it later, it'll be the main part of the show for now at least. Everything's always editable. And we have our 4 hydrogens. I'm gonna throw down my oxygen first, because I feel like it's better to place down the elements that can have more than 1 bond, just that it's a little bit more versatile. So we have, oh, maybe I should have put the dots. Oh well. We have oxygen, and then oxygen is gonna have its octet. Octet rule always. The octet rule is only non-applicable to hydrogen and helium, which is why you only see those hydrogen with 1 bond instead of 4. We should have a hydrogen here, should have a hydrogen here, should have a hydrogen here, and I'll throw one for here for giggles. Okay, so we have octet here, and we have another octet here. Yay, we satisfied the octet rule. C H 2, 4, 6, 8, 10, 12, 14. So not only this is our total number of valence electrons, and this here satisfies all the requirements. But do you see how I kind of positioned the oxygen in a place where I knew it could be versatile and kind of like my quote-unquote wild card, I want to say? Like, if carbon is your starting point and your hydrogens are your end point, your oxygen would be your middle point, where everything will help. It helps everything fall into place. So you will definitely see when you're going to need to throw in your oxygen. And I feel like, yeah, this concept is all about winging it. And if you have your basics down of knowing how to calculate your valence electrons, knowing the octet rule, knowing the duet rule, then I think you will be just fine, even if you don't fully get it, because I'm not sure if he's expecting us to. I'm sure you do want to fully get it, and if you do, please go to the chem tutorings. Just go. I know Hogin has one on Thursdays in the library.